Let's try to trap some water today. Storing rainwater in a code. Interesting. Hi coders, I am Shraddha and let's figure this out together. So today's problem is LeetCode 42, trapping rainwater. And honestly the problem statement does not explain much. It is just a one line. So actually let's see what's going on. And when I saw this for the first time, I also didn't get it. So we are given an array like this. And problem says these numbers represent an elevation map, which basically means vertical bars like shown in the image, and each bar has width 1. Now elevation map sounds a bit confusing, so let's simplify it. You can think of these bars as a buildings of different height. Now imagine it starts raining. Water on top of a building will just slide off, but water between buildings can actually get stored. Means between the gap the water will get stored. So our task is to calculate how much total water gets trapped between these buildings. Now I am a beginner. I look at this problem and my first thought is, okay, let me just look at the array and manually figure out how much water is trapped at each position. Let's start with just one building, height 4. Can water stay here? No, because water needs wall on both the sides to stay, and here we don't have anything, so water will fall off. Now let's add one more building, height 2. So now we have 4 and 2. Can water stay on top of 2? Still no, because even though 4 is taller than 2, we don't have any building on the right side to hold the water. So water cannot be trapped. Now let's add one more building, height 0. Now it's 4, 2, 0. Can water stay on 2 or 0? Still no, because again we don't have a boundary on the right side. Even if left side is taller, water will just flow away. Now let's add another building, height 3. Array is 4203. Now look carefully. For height 2, we have 4 on the left, which is taller, and 3 on the right, which is also taller. So now water can be trapped on 2. And for height 0, we also have taller buildings on both the sides. So water can be trapped there as well. This is the key idea. Water gets trapped at a position only if there are taller buildings on both the sides, and it will fill only up to smaller one. Now why only up to smaller one? If you have seen my last video, you might already know this, but if not, let's quickly understand. Imagine two buildings, one of height 8 and one of height 3. Water will start filling, but after height 3, it will spill from that side, as you can see in the video. So water can never go above the smaller building. So now let's calculate. At height 2, left side tallest, height 4, right side tallest, height 3. So water is equals to 3, the shorter one, minus 2 is equals to 1. At height 0, water is equals to 3 minus 0, which is 3. So total water is 4. You understand the pattern more clearly. Take a smaller example. This is the array. Water on 0 equals to 4. Now increase the height of the middle building. Water is now 3. Again increase the height of the middle building. Water is 2. Again increase, water is 1. Also look at this. 6, 4, 8. For 4 on left side is 6. On right side is 8. Both are taller than 4. So water will get stored. But how much? The shorter one, 6, minus its own height, 4, is equals to 2. See this example, 8, 4, 6. For this you calculate and tell me in the comment section how much water gets trapped. So what is happening? Water always depends on the smaller boundary. So for any position, we need the tallest building on the left and tallest building on the right. So now we discovered the formula for calculating the water. For a particular position, find the tallest on the left, find the tallest on the right, take the minimum from the both and minus the height of that particular building. So water is equals to minimum of leftMax, rightMax minus height of that building. So the brute force solution would be, for each element, find the tallest building on the left, find the tallest building on the right, take the minimum of those two and subtract the current height. that gives the water stored at that position. But we are doing a lot of repetitive work, so let's optimize. What if we keep track of leftMax and rightMax? And since we are dealing with left and right, let's use 2 pointers. Let's try it. One at the start, one at the end. We keep left at the start, right at the end, because water depends on the left boundary and the right boundary. So we start from both the sides and move inward. Now the most important idea. Water depends on the smaller side. So if left side is smaller, we process the left. If right side is smaller, we process the right. And what do we do at each step? If current height is greater than or equal to max, which means we found a taller building. Otherwise, we add water. Max minus height. Now, let's dry run this. Left equal to 0, right equal to 5, currently no water. Move left. Left max becomes 4. At index 1, water equal to 4 minus 2, which is 2. At index 2, water equal to 4 minus 0, which is 4. At index 3, water 4 minus 2, which is 2. So final answer, we calculated 2 plus 4 plus 1 plus 2 equal to 9. And that's our answer. To understand the idea, let's quickly look at the code. We are using the 2-pointer approach here. We start by initializing 2 pointers, left at 0, right at the last index. We also keep 2 variables, leftMax and rightMax. These will store the tallest building we have seen so far from the left and right. And we also keep a variable called water to store the total trapped water. Now we run a loop while left is less than right. Inside the loop, we compare the height of left and right because water always depends on the shorter side. I am saying this again. So if left height is smaller, we process the left height. First we check is the current height greater than or equal to left max. If yes, we update the left max because we found a taller building. Otherwise, we can trap water here. So we do water is equals to water plus left max minus current height, and then we move the left pointer forward. Now if right side is smaller, we do the same thing on the right. We check if the current height is greater than right max. If yes, update the right max. Otherwise, add the water. Water is equals to water plus right max minus height, and then move the right pointer backward. And we keep repeating this until left and right meets. Finally, we return the total water. So this is the complete code, nothing complex, just tracking the max values and moving the pointers. Draw a diagram on paper, dry run, and you will understand it. If you understood, let me know in the comments, and if you have any suggestion, I would love to hear them. Do like and subscribe to Let's Crack It. Thank you for watching. Happy coding.